Good afternoon, everyone. Welcome. My name is Jeff Brown, and I'm one of the co-founders of the Grails framework. I work on the Grails framework at OCI, and I'll talk a little bit more about OCI in just a minute, but a couple of other things we'll start with. So I live in St. Louis. How many of you ever been to St. Louis? Yeah, half the room or so. St. Louis is a great place to visit, great place to live. Lots of great food, fun music. Of course, that's the Gateway Arch. This picture is taken either from a boat on the Mississippi River or on the other side of the river from Illinois. You're looking into downtown St. Louis there. St. Louis is a great place. I like St. Louis a lot. I've lived there since 1980 or so. I encourage you to come visit. We've got the world famous St. Louis Cardinals, one of the greatest Major League Baseball teams of all time. Are there any Cubs fans here? Eric's a Cubs. We got a couple of Cubs fans. All right. So come to St. Louis. Let me know you're coming. We'll find a good place to eat, and if we can make it to a Cardinal game, that's what we'll do. That's not really my wife and kids. It's just a picture of them. Right? For the Cubs fans, Eric, and there was one other Cubs fan. I want to point out that you probably don't know what this is. This is the trophy that you get when you win the World Series. So. Leave that there for a moment for the Cubs fans to see what that looks like. Okay, so you're familiar with that. All right, so on with more serious business. We're really excited to share with the community that the Grails team, myself, Graham, Dave Klein, Colin Harrington, we're actively growing the team, but the Grails team is at Object Computing Incorporated, OCI, which is based in St. Louis, Missouri. And it's really great to be at an organization that is fully behind the technology. We're committing all the resources that we can to moving the technology forward. We're addressing all the concerns that the community is coming to us with. We're moving the framework ahead with more momentum than ever before, and I couldn't be more excited about our new home at OCI. Visit ociweb.com/grails for more information. But just quickly, OCI is providing a full service package around the framework. So that includes consulting services and training, product support. We're doing a lot of product development with clients and doing everything that we need to be doing to support the framework and enable more and more organizations to be successful with the framework. And as I said, it's just really great to be at an organization that is so committed to moving the technology forward that I just couldn't be happier about that. So I've got nothing but fantastic things to say about what's going on at OCI right now and what will be going on in the coming years. Stop by our booth out here if you'd like to talk to us about anything. Already just today, in the few hours that I've been here today, several folks have come by with a laptop and some code, and we've troubleshot. There's one right there. Done some troubleshooting and fixed problems real time right here in the hall. So come by and talk tech or get whatever questions you've got answered while we're here. There are, I think, 7 of us from OCI here. Almost always there'll be at least a couple of us out at the table. Please come let us know if there's anything we can do to help you out. And we are growing the team. We've got all kinds of Grails-related work going on right now. We've got Grails project work. We're spending a lot of effort migrating Grails 2 plugins to be Grails 3 plugins. Of course, a lot of you who have looked at Grails 3 are aware of this situation, and that is that Grails 2 plugins are not compatible with Grails 3, and that was a design decision that we made fairly early on, that was just going to have to be the way forward. So there are, I think, 1,100 or something like that Grails 2 plugins out in our public portal, and not all 1,100 of those plugins have been ported to Grails 3. Most of the most important ones have been ported. We felt it was critical that we port at least the really must-have plugins before we released Grails 3. And we did that. We ported like the Asset Pipeline, Hibernate, not Tomcat because we get that from Spring Boot, but all the really, really critical plugins that you can't do anything with Grails without. Those were ported before we released Grails 3, and in the months since we've released Grails 3, we've been actively porting more and more. In recent weeks, we've ported the Quartz plugin, a JMS plugin. It's a long list. So we're actively migrating Grails 2 plugins to Grails 3 is another piece of work that we've got going on. New plugins are being developed for Grails 3. We're growing Gorm. Gorm is one of the most compelling parts of the framework, and we're growing Gorm's reach to reach out to more and more data stores. Gorm is really a misnomer now. It's not that the R doesn't make sense anymore, right? The R is object to relational mapping, and Gorm is much more flexible now than it was in the very early days of Grails. So you're not only does Gorm allow you to talk to just about any relational database, now you can talk to lots of different, even non-relational databases, Neo4j and MongoDB and Cassandra and Redis. And so Gorm has sort of outgrown the R in ORM, but the name sticks. So we're growing Gorm. We're developing new application profiles. Application profiles are a really important part of the Grails 3 story. I don't want to spend a whole lot of time talking about that. I want to get into the microservice stuff, but the point is we've got lots of Grails development work going on, and we're actively growing the team. And if you're interested in talking to us about maybe working with the team, please send us a resume or contact us at grailsjobs@ociweb.com. I would love to hear from you. If you'd like to talk while we're here this week, just come let me know, or anyone at the table. And we'd be happy to talk with you. But I want to just emphasize to the community that we are hiring, and would love to talk to you if you've got some Grails expertise and interest in working with the team. Good. So as we move along here, I'm going to talk about some ideas kind of at a high level, and then we're going to talk about some API stuff and see what some of the API looks like inside of Grails that relates to REST and publishing microservices. And then I'm going to jump out into an IDE, and we're going to write some code and run some kind of small simple demo apps. As I'm moving through this, if you've got any questions or comments or anything at all, please raise your hand. Don't feel like you have to wait to the end for Q&A. Make this as interactive as you like, and that's not a problem. So if you've got questions as we're moving along, please get my attention and be happy to address that. So microservice, I'm going to talk a little bit about, we're going to talk about microservices, but I'm really going to focus on a lot of the REST capabilities provided by the framework as that relates to building microservice architecture style applications. We're going to talk mostly about REST, but that's an important part of building, taking advantage of this idea of microservices. So at the highest level, the sort of the shortest, most simple definition of the kinds of what I'm talking about is microservices are just what the name suggests. They're small services. So instead of having one big application, one monolithic application that has everything, that satisfies all of the requirements, maybe we break that thing up, decompose that into some number of smaller pieces. So we've got a piece over here that does all of the reporting work, and another piece over here that does the accounting or the math calculations. And so we've broken the application up into micro pieces. Instead of having one big monolith, we've got this microarchitecture, and all these pieces can communicate with each other over REST would be the most common way to do that, and that's what I'm going to demonstrate. But these individual pieces are independently revisable, right? I can deploy a new version of this service without deploying a new version of the whole entire application. That's a really nice piece of flexibility. There's also some complexity that comes with that, right? If we've got version 1 of this service and version 1 of this other service, and they're compatible with each other, and I rev one, I need to make sure the two are still compatible with each other. And if they're not, maybe I do need to rev them both. We'll talk a little bit about versioning services and see some really slick things that Grails can do. Simple, but really slick things that Grails can do to help you with that. So microservice architecture is an architecture in which you've broken the application needs up into smaller pieces than they might otherwise have been. Those smaller pieces are independently deployable, testable, updatable. You can have different rules for security imposed. There are lots of reasons that you might want to build applications in that style, and that idea is pretty well accepted at this point. So most of the time I'm going to spend today is not talking about why you want to do this, but look at some of the details of how you want to do how you can do this with Grails 3. So in Grails 2, Grails 2.3 I think is when we introduced this, but in Grails 2 we introduced a good bit of what I think is really impressive, really slick support for building REST applications. So from the very beginning, Grails 1 had support for building REST applications. You could build REST applications with Grails 1.0. And as the framework has evolved over the years, REST is one of the things that's gotten more and more robust and kind of more has become a more and more impressive part of the framework. This particular feature is one that was introduced, as I said, I think in Grails 2.3. It's not new in Grails 3, but certainly still works in Grails 3. So in my URL mappings config file, I can define a URL mapping like this. So /people is just a label. It could be anything, right? So /people is going to be the URL that I want to use to access my person resources. So we've got a simple hello world app that manages person objects. So a person has a first name, a last name, and an age, and an address, or whatever it is that describes a person. And I want to build a RESTful application. I want to provide a RESTful interface to interact with that collection of persons. So I can have just this one URL mapping in my URL mappings.groovy file, and from that comes a whole bunch of, or not a whole bunch, but a list of endpoints that we'll see here in a minute. So notice that the URL is /people. The value of the resources attribute is person, and what that means is every request to /people and several URLs below /people that we'll see in a minute, like /people/ some number, or /people/ something. All the URLs at /people and below will all be handled by the person resource. And what that really means is all of those requests will be handled by the person controller. So imagine you've got a person domain class that defines a first name, last name, and age, and you've got a person controller, and you want to build a RESTful interface that you want to provide a bunch of URLs that lead to that person controller for managing those person instances. So /people is the URI that I want to associate with that. And this list right here probably clarifies a lot of that. So if I send, with that URL mapping in place, just the one URL mapping you see at the top, I want to be clear, you don't have to provide mappings for all these things in the table, just the one mapping at the top. The things in the table are the product of that one mapping defined at the top. So let's just step through this. So if you sent a GET request to /people, right, and /people is the URI at the top of the slide there. If you sent a GET request to that URL, by default, that's going to execute the index action in the person controller. All right, so you could wire all that up. Grails developers know how to define URL mappings. So I could have a URL mapping for /people that goes to the index action of the person controller. And then separate from that, I could have another URL mapping for /people/create. And that could go to the create action in the person controller. I could define all these URL mappings sort of independent of each other and be explicit about what controller and which action is associated with each of those URIs, but all of that comes out of using the resources syntax that you see at the top. So notice the first and the third URL mappings there. They both go to /people, but depending on which HTTP verb you're using, the HTTP verb that you're using dictates which controller action gets invoked. So if you send a GET request to /people, that'll be handled by the index action in the person controller. But if you send a POST request to that exact same URL, that'll be handled by the save action in the person controller. Again, you could do that before this resources support was added to URL mappings, but it was more tedious, right? You had to define the URL mapping yourself, and then there's a syntax for saying if it's a GET request, go here, and if it's a POST request, go here. These are all sensible defaults for how you probably want your RESTful URL mappings configured. So we've provided a mechanism that makes it really simple to create all of those URLs. Right, so a GET request to /people will be handled by the index action. GET to /people/create will be handled by the create action, and so forth. So you see there are 7 URL mappings there. And all the places where you see an ID surrounded by curly braces, that would be a placeholder for a unique identifier. So for example, if we look at the 4th URL mapping from the top, if you sent a GET request to /people/9, the number 9, what that's going to do is retrieve a particular person, right? It's going to retrieve the person whose ID is number 9 and then render that person somehow. We'll get to the somehow. It could be a browser page, or it could be some JSON that gets rendered. But somehow a representation of the person whose ID is 9 is written to the response. And you've got some flexibility around that we'll talk about. Yeah, so we've defined one URL mapping in our URL mappings.groovy. All these mappings come out of that, and so that's our first look at some pretty slick capability provided by the framework to really simplify what it takes to build RESTful APIs in Grails. Does all that make sense? Excellent. So one of the challenges with building out and deploying these kinds of microservice type architectures is what I mentioned briefly earlier, and that is as you come up with new versions of particular services, it may be the case that you need to leave the old version out there concurrently with the new version. Maybe you've got partners who rely on version 1 of the service, and you don't get to update those clients when you update the service. You want to update the service to provide some new capabilities, but you need to do that in a way that doesn't interrupt the existing clients that are out there in the wild sending requests to version 1 of your service. So when you define these URL mappings, you can specify a version for the URL mapping. There are a couple different ways to go about this. This is one piece of how you might solve this problem. So here I'm specifying /people/v1 should be associated with the book controller that's in the v1 namespace, and then people/v2 should be associated with the book controller in the v2 namespace. So in your controller source file, you can declare a namespace for a controller. You say static namespace equals v1 or v2, or it can just be a string. It doesn't have to be a number. It's just a label. And this is one way to set up a RESTful interface that maps 2 different URLs to 2 different versions of the same controller. And this is kind of the crude way to do this. A more sophisticated way to do this is what's represented here. And so notice there are 2 key differences between the mappings in the middle of the slide versus the 2 mappings at the top. There are 2 critical differences. One is the URLs are different. At the top, I needed 2 different URIs, /people/v1, /people/v2. Those are 2 different endpoints that go to 2 different places. So they're really not related to each other as far as the framework's concerned. They're 2 different URLs, 2 different controllers. Maybe they happen to be 2 different versions of the same functionality, but as far as the framework's concerned, they're just separate things, and you've set up mappings for them. The second approach is different than that. What we've done is we've set up the same URI, so /people can be used to access version 1 of the book controller or version 2. In this case, they happen to be two different namespaces, but we could set this up so that /people, we could leave the namespace out and still take advantage of this version attribute. And how that version attribute comes into play is if the request includes a header that specifies which version of the resource or which version of the service is being accessed, that's a way for the request to dictate which of these mappings should be in place. So you've put your service out there, and you've published it to your clients, and you've told the clients, okay, when you want to retrieve people, send a GET request to /people, and send us a request header that says that the version you want is version 1. So that's information you've relayed to the people who are going to be calling your service. You've published your service. That's all out there and operational, and everything's cool. Then you evolve your service and you introduce version 2, but you want to leave version 1 in place and continue servicing requests that are coming in for version 1. You can leave everything that's there today in place and introduce a new version of your service, like the last mapping you see here, and now tell your clients when you're ready for version 2 of our service, just change your accept header. Everything else stays the same, the URL stays the same. Change your accept header to tell us that you want version 2.0 instead of version 1.0, and now they'll be accessing the new version of the service. Yeah, you've got a question? Yeah, so the question is there a way to express which version of the service should be accessed if the accept header is not present in the request? Is that right? There is, and I think what happens is the highest version number is the one that we're picking by default. I think that's what happens. 95% sure that's what we're doing with that. But there is, and it's documented in our user guide, it's a reliable selection mechanism. And I'm pretty sure it's the highest version number. But the request header does not have to be there. If the request header is there, then it needs to match one of the versions that's expressed in the URL mappings. Otherwise, you'll get a 404 because there is no URL mapping that matches the incoming request. Other questions about that so far? All right, so if we had this service up and running and we sent a request like that, that will, like you see in the curl command down there, that looks like that's going to access version 1 of our book resource, and whatever the people, the index action in our person controller returns, that's what's going to be returned from that request. Good? All right, so for all of that to work, let me go back to the first example that we looked at. For this to work, we have to have a person controller, right? So /people is just a label that we're using in our URI. The thing after resources, the string person, that corresponds to the name of a controller that has to exist in this app. There has to be a person controller for that to work. Same with all this. Here we've got to have a book controller for any of that to work. Another way to approach some of this is you can build that same kind of interface, that same kind of REST API without writing any controllers at all. So in the examples we just looked at, we probably had a person domain class that we didn't see represented, but a person domain class or a book domain class, and we had a controller for providing access to instances of those things. So here's a way to build that same kind of behavior out without needing to introduce a controller. So car is my domain class. So this is under Grails app /domain/demo/car.groovy, right? So this is a domain class. And what's relevant here is I've annotated the domain class with @resource. @resource is a Grails annotation. It's in the Grails.rest package. And when I annotate the car domain class with @resource and specify a URI, it's as if I had written or generated the car controller and used a URL mapping like this, right? It said /cars resources :car. But I've still got the car domain class and the car controller out there. When I'm using the @resources annotation, I don't need the controller. Turns out that the controller is there, you don't ever see it, but the framework's generating the controller for you. And it behaves, all of the same URL mappings will be in place. The controller will behave the same way as if you had generated the default controller. All the same data binding stuff. That we haven't talked about the data binding yet. I'll get to a little bit of that later. All the same behavior would be in place here versus the approaches that we described earlier. But I don't have that additional source file. I've defined my domain class, which has to be defined. And that's the only class. So I could create a brand new empty Grails application and put nothing in it but this class, and we could start that up and send GET requests and post and put. We'd have a fully functional REST API in place for managing car instances. Right. Does that make sense? So the controller, so if you're going to write a controller, again, if you're using this approach, you don't even have to write the controller. The controller gets generated for you by the framework. You never see it, but it's there. But you might want to provide that controller, and we'll talk about why you might want to do that. So here we see a class called person controller that extends Grails.rest.restful controller. So of course that RESTful controller is a controller that's provided by the framework, and it's genericized, so you need to specify what type of object this controller is providing access to. So in this case, it's a RESTful controller of person. So we've got to override the default constructor because we have to pass the person class up to the superclass constructor there on line 8. But the interesting bits here would be around lines 12 or line 19. So if all you were going to have in this controller was that constructor, there's no reason to write the controller at all. That's what we would get by default if we did something like this, right? So the reason that I might want to provide this controller is I want to change the default behavior I want to change the behavior that the default controller would have. And there are a number of ways that a number of reasons you might want to do that, and a number of ways you might go about it. Really, two of the most common reasons that you might want to customize the default implementation of the RESTful controller are represented here. So I'll talk about each of these. One of the things that you might want to override from RESTful controller, the parent class, is a method called query for resource. The query for resource method is genericized, so its return type needs to be the type that you specified up in the type declaration up at the top. So it returns a person object. And there are several places in RESTful controller where a query needs to be sent to the database to retrieve a person. So you might be retrieving a list of all the persons. You might be retrieving a particular person to show their details. You might be retrieving a particular person to update it, right? We're going to change a person's last name or something. There are a number of places in the RESTful controller where a query has to be sent to the database to retrieve a person. The default query for resource method that you inherit from RESTful controller, I'm going to simplify it a little bit, but basically what it does is it sends a query to the database to retrieve the person whose ID is whatever the argument, they're on line 12, whatever argument is passed into this method. So typically this would just be person.get, and you'd pass ID as an argument, and whatever's returned from that is what would be returned from this method. That's what the default version does. You might want to customize that for some reason. Maybe you've got some additional criteria that you want to plug into the query that's going to be sent to the database. So a way to do that is write your own controller class that extends RESTful controller, inherit all the default behavior except for this, right? You want to override just the query for resource method. And note that you're never going to write code that calls this method, right? I suppose maybe you could, but in general, you wouldn't write code that calls this method. This method is being called by other methods that are defined in RESTful controller. You are given an ID, and it's your responsibility to return a person. The most common thing to do would be send a query to the database, but it doesn't really matter. As far as the framework's concerned, do whatever it takes in this method to come up with a person object and return that person object. So as I said, the default implementation calls person.get and passes ID as an argument, but you might want to have some additional criteria, and that's what would be represented on line 14. And a little bit later, when I get into the sample app, the microservice demo app that we're going to look at, we'll see kind of a realistic example of why you might want to do this. But this is how you would do that, right? So extend RESTful controller, override query for resource, and then you define whatever it takes to go find the person that corresponds to that ID. Does that make sense? Yeah, question?
Yeah, the serializable there, I'm thinking that probably the parameter goes through a series of transformations. By the time it gets here, it becomes serializable.
The question is that he assumes that the parameter goes through some transformations, and by the time it gets here, it's made serializable. Is that right? That's sort of true. There's really no transformation going on. It's serializable the whole way, right? So if your ID is along, that thing is serializable. So it's not the case that we're ever transforming anything into a serializable. It's going to be a serializable the entire time from front to back. Yeah, does that make sense? Yeah. Other comments about query for resource? The other method that we see overridden here is get object to bind. So there are a number of places in the RESTful controller where data binding has to happen. There's the data binding mechanism in Grails, especially in Grails 3 and on. So I'm sorry, Grails 2.3 and on. Is the data binding mechanism, I think, is really impressive. It's a really flexible, really powerful data binding mechanism. So most Grails developers don't really even think about everything that's going on there just because all the cool stuff just happens and then you get on with your business. But you can do things like create a new person class and pass the request params object, the whole request params map, as an argument to the person class constructor, and that will invoke the data binding mechanism. The data binding mechanism knows how to do all kinds of sophisticated stuff like simple things like type conversions. So your request parameters are all going to be strings, but when you bind those strings to longs or doubles or booleans, there's conversion stuff that has to take place. That's not particularly impressive. That's the sort of thing you'd expect from the data binding mechanism, but there's a bunch of really robust, sophisticated stuff in the data binding mechanism inside of Grails that eliminates lots of code that you might otherwise have to write. So there's sophisticated stuff in the data binder that can bind an entire graph of objects. So if you've got request parameters like person.address.city, the binder can break those things up based on the dots and build out the entire object graph. So a person has an address and an address has a city and so forth. The data binding mechanism is really quite sophisticated. So there are lots of places in several places in RESTful controller where data binding has to happen. So one is, imagine that you're creating a person and you're using a browser, right? So you're filling out an HTML form and you type in their first name, last name, and age and click submit. So when you click submit, an HTTP request is made to the Grails application, and the Grails application is handed basically a map, the request parameters, and it needs to use that map to initialize a new person object. So the map is passed as an argument to the person class constructor, all the data binding happens, and now you've got a person that's been constituted with whatever values were present in the request parameters. Other places in RESTful controller where data binding has to happen is the same sort of thing, but instead of creating a person, you're updating a person. So you're editing a person, you change their last name and click save. A request is sent to the application with enough information to carry out the update. So it could be the case that the person class has 100 attributes. Don't define domain classes that have 100 attributes. That's a bad idea, but you could do that. And maybe you've got a form that just allows you to update 2 of those attributes. You've got some checkboxes or a place where you type something in. So the form only accounts for 2 of those things. You fill out the form and click save. The request that goes to the controller or goes to the web app wouldn't necessarily have all 100 attributes. It would just have the things that were present in the HTML form and probably the ID of the object. So that ID might be implemented as a hidden form field. So the request comes into the app, you've got an ID and 2 attributes. The data binding mechanism knows to use that ID to go find the corresponding entity from the database, and that it can bind the other 2 request parameters to that entity. So there are lots of places in RESTful controller where that kind of data binding happens. And by default, what happens inside of that get object to bind method is what's returned is the request object. And I should represent this in slides, but I haven't. So I'm going to jump out to an editor here and talk a little bit about this. So if you had def p equals, so we retrieve a person from the database whose ID is 42. This is inside of a Grails controller here. So you might do something like that, right? You might say p.properties equals params. And what that will do is map, it'll impose data binding using the request parameters as the binding source, right? So the request parameters is just a map that includes all the request parameters. Another thing you could put over here is the request. You can bind the request. The request itself can be the binding source. The thing that's being bound to the person could be the request. And the reason you might want to do that, I should have looked up there. Is that legible? Are you guys even seeing what's up there? Somebody in the back? Okay, good. Yeah, so a reason that you might want to use the request as the binding source as opposed to the request parameters is the request is a little bit more flexible. So what will happen when you use the request itself as the binding source is the framework will look at the request to see if the request has a body. So maybe this was a request that included a bunch of JSON in the body. As I said, the framework will look at the request and see if there's a body, and if there is a body, the body will be read and parsed, and that'll be the binding source. So it could be JSON, could be XML, could be HOW, could be any of a number of formats. But the body of the request will be used as the binding source. If the request does not have a body, then the data binding system will recognize that and will retrieve the request parameters from the request and use the params as the binding source. So it would be as if you had done this, but it's more flexible, right? Because if we're going to do that, then we've got to have code in our controller that says, just sort of pseudocode, does the request have a body? And if it does, then do this, right? Else do the other thing, right? So you don't want to have that logic in your application. You could do that, and that would work just fine, but you could skip all of this except for that right there, and you'll get the exact same behavior, right? So just use the request as the binding source, and if the request has a body, that will be used, and if the request doesn't have a body, then the request parameters will be used. How that relates to this is whatever is returned from get object to bind, that's going to be the thing that will be used for data binding. So the default implementation returns the request, which is what you most often want. But you can return whatever you want from this method. So a common reason to override this is you want to add things to the map that's going to be used as the binding source, or maybe you want to subtract things. Maybe there are things in the request that you don't want to participate in binding. There are several ways to go about that. One way would be to strip them out of whatever's being returned here from getObjectToBind. So as an example, you could create a map inside of getObjectToBind and return the map at the bottom, but in the middle, you can populate the map with whatever you like. So you can look at the request parameters and put whatever is appropriate inside the map. But whatever is returned from this getObjectToBind method, that's what's going to be effectively on the right-hand side of the equals when you do something like p.properties equals x. So the x, the thing that's on the right-hand side of the equals, is whatever's returned from that getObjectToBind method. And my laptop just locked up. So we're going to give this a moment and hope that it returns here. Otherwise, we'll give it the hard boot. But my laptop's not responding right now. Yeah, so while I'm waiting for that to hopefully come back, so the two methods that we overrode were getObjectToBind and query for resource. Query for resource has one argument, and that one argument is the ID of the thing being retrieved, and getObjectToBind does not accept any parameters and behaves as I just described. And my laptop's not coming back. That's bad. Here we go. I'm going to unplug that for just a moment. That didn't help. Let's see if we're back in action here. My boss is here. I might have to put in a plea for a new laptop here in a minute. All right, we might be back in business. All right. Questions about extending RESTful controller and overriding methods like query for resource or getObjectToBind. The idea is that the default behavior that you get when you do this is going to be good for many applications, and when you want to customize that behavior, the way to do that, or a way to do that, is to write a class that extends RESTful controller and then plug whatever capability you like in there. These are two common methods you might want to override, but you can override any of the actions like list and create, or not list, index, create, delete, save, the default scaffolded actions that Grails developers are used to seeing. All right. Let's jump. We're going to come back to the slides in a moment, but I want to jump into some real application code here. And we're going to look at this cars application. There's very little code in this application. Don't worry, we're not going to write more, but I want to demonstrate what's here now. All right, so I've got a car domain class that has a make, a model, and a price. So that's my model, very, very simple model. I've got a controller that extends RESTful controller, and overrides this list all resources method. We'll come back to that in a minute on the second pass. We're going to visit this twice. During this first pass, this bit's not relevant. We're going to get back to that. But I've got a controller is what's important, and I've got a car domain class, and in my URL mappings, this bit right here is all that's relevant so far. So I've got a URL mapping that maps /automobiles to the car resource. So that means all requests to /automobiles will be handled by the car controller. And again, this mapping will come into play in the second pass when we come back to this application. So let me come out here and run that application. It's a Grails 3 application, of course. And literally the code that I've pointed out is all the code that I've added to the app. So we've got a URL mapping. We've got a controller that we really don't even need yet. This part down here we'll get to later. And I've defined my domain class. That's all that's there. So it looks like the application is up and running on port 8084. And rather than make you watch me type curl commands, I'm just going to copy that to the clipboard, paste that. So I'm sending a GET request to /automobiles and asking for JSON back. So we see a list of cars. It's a little bit hard to make out there or parse there in the console, but there are 3 or 4 cars. I see a Ford Fusion that cost $22,000. I've got a Plymouth Duster that cost $200. That was my first car, a 1971 Plymouth Duster that served me just fine for several years for $200. And I've got a Chevy Corvette here for $45,000. So we've got several cars in the database, and we're going to need several cars at several different price points to demonstrate something else in a bit. But at this point, what I'm demonstrating is that I can send a request to that URL, and I get back a JSON representation of all of the automobiles that are in our system. I should point out where those cars are coming from. If we look at the Bootstrap class, we'll see that I've got code in Bootstrap that is creating those cars. Right? So we've got Ford Fusion, a Plymouth Duster, and a Chevy Corvette there. All right. So if I were to come back here and copy this other curl command. So what that curl command is doing is it's sending a post request to the same URL. Look at the very end here, /automobiles. Maybe I can get this to fit. I'm sending a post request to this URL, not a GET request, a post request. I want JSON back, right? That's what's represented there. The request will have a body that is also JSON. They wouldn't have to be the same, right? I could send XML and expect JSON back or vice versa. But I'm sending, this request will have a body. And notice that the body of this request has a make, a model, and a price. So the make is called my make, the model is called my model, and the price is $185,000. So when I send that post request to our application, that worked. What I get back is a JSON representation of that car that we just created. And if I go back to the first command, here's the new car that we just created. Right? So all that's really being demonstrated so far is that we've got a REST API in place. I can send GET and POST requests to this thing to create cars, to retrieve details about cars, and I could generate more commands to update existing cars. But the whole API is in place with all of these mappings that we talked about earlier. /p instead of /people, it'd be /car and so forth. Right? Questions about what's there so far that I've covered? Right. We've written very, very little code and said a lot of words to describe them, but there's not very much code there, and we've got some pretty sophisticated capabilities in place. All right. We're going to come back to that code in just a minute. In Grails 2, there is a REST Client Builder plugin. So the REST Client Builder plugin provides this REST Builder class that makes it easy to make REST calls. And this is useful in building microservice architectures because often the services need to communicate with each other. And we're going to evolve our application where we're going to have 3 different apps running and they need to communicate with each other, and they're going to do that over REST. So the REST Builder is how we're going to carry that out. So in Grails 2, there's a REST-client-builder plugin. And the plugin doesn't really do anything other than introduce a dependency on the library that includes the REST Builder class. That library and some of its support classes have been moved out of the plugin where they used to be in, and now they've been moved into Grails data mapping. Grails data mapping is a project that's important. It's a core part of Grails. A lot of Grails developers don't realize it's there because it's just part of the Grails framework from the user perspective, but it is a whole separate library that's bundled with Grails. And it's got a whole bunch of modules. So there's a Hibernate module and a Neo4j module and a Cassandra. There's a whole bunch of pieces of Grails data mapping. One of the pieces of Grails data mapping is Grails Data Store REST Client. And so we thought about, in fact, the plugin is out there. The source code is out there for the Grails 3 version of the REST Client Builder plugin, but it's empty. It doesn't do anything other than add a dependency on this. So it's debatable about whether we should even have that plugin. This is all the plugin does. So if in your Grails 3 application you have this, you've got what behavior would be there if we published the plugin. So maybe we'll come up with some motivation to evolve the plugin a little bit and publish it, but I don't know that that's going to happen. One way or the other, we want to get the REST Builder class into our application. This is a way to do that in a Grails 3 app. So if I were to go look at, here is, let's see, web UI at this build.gradle file, we'll see that I've got an app that has just that. This is copying, this is exactly what we were just looking at in the slide. So that is going to pull a class, it's going to pull a number of classes into my project, and one in particular, that the one that we're after is a class called REST Builder. That's this guy right here. All right, we'll come back to that REST Builder business in just a minute, but that's what's going on here. We've expressed the dependency on Grails Data Store REST client, so now the REST Builder is in our application. And the REST Builder, as I said, is a class that makes it just drop dead simple to create REST requests. So here's the simple example. So this is sending a GET request to someapp.com/data, and we get something back. And if I refer to the .json property of that something that I get back, then that will be the JSON that was in the response. And you can do a lot more with the REST Builder than what's represented here. But I don't want to go too far down that rabbit hole. But the REST Builder is a simple way to create REST requests from a Grails app, or really from any Groovy application, and we're going to take advantage of that. So let's see what that looks like. All right, so the car application, we've got 3 applications here. I've got a cars app, a bank app, and a web UI app. 3 separate applications. The cars class the cars app is the only one that we've really looked at so far. And there's not a whole lot of code in the cars application. Remember that all that's here is this this domain class. We've got the controller that looks like that, extends RESTful controller, and then in my URL mappings, we've got the one URL mapping that maps /automobiles to the car controller. That's all that's in the cars app. We've got another app out here called Bank, and the Bank app defines banks, right? So a bank has 2 attributes associated with it. A bank has a name and has a max loan amount. That's the maximum amount of money you can borrow from this bank in order to go buy a car. Maybe you could use the money for anything, but we're building a car system here. And there's no bank controller, right? The controllers folder is empty except for the URL mappings. There's no bank controller. I've annotated the bank class with that @resource annotation that we talked about earlier, and specified that I want /banks to be the URL that can be used to manage bank objects, right? That's what the value of URI is there. And then this is the request and response formats that this particular application will support. So most applications are going to support JSON. You can support XML. You can support any of a number of MIME types. JSON and XML are probably the most common. So that's the bank application, and I don't think there's anything else in this app other than in Bootstrap. We've got some code that creates some. I want to be down here in the init block. In Bootstrap, I've got some code that creates some banks. So there are 3 banks in the system when the application starts up. There's a Richie Rich bank, a working man bank, and a poor man bank, right? And the difference between these banks is the amount of money that they're willing to loan you when you want to go buy a car. So if you go to the Richie Rich bank, you can borrow up to $200,000. If you go to the working man bank, you can only borrow $30,000. And if you go to the poor man bank, you can buy a 1971 Duster in 1987. I don't know what that Duster would cost you today. But the poor man bank will only loan you $200 to buy a car. Here's an interesting feature that doesn't really have anything to do with Grails or microservice, but I like. Is that news to anybody, or anyone puzzled about that underscore there? Never seen that? I'm sorry? It is not Java 8. It's all Groovy code, and that's been in Groovy since I think the very beginning. But in Groovy, you can embed underscores just in random places in a number. You can do this if you want. Don't do that. There's no good reason to. But there is good reason to do this, right? So especially if you've got a long number, those are commas effectively in the number. So it's an easy way to represent large numbers, right? So contrast looking at that. That's pretty obviously 200 million, where if you take the underscores out, I don't know how many that is. I have to count them, right? So that's a neat little language feature that a lot of people aren't familiar with. There you go. All right, so we've got 3 banks in the system, and the difference between these banks is the names and more importantly, the amount of money that they're willing to loan you to buy a car. All right, so we've got the car application running right now. I don't have the bank running yet. Let's start the bank up. And once the bank, so these are our microservices, right? We've got a car service that just provides access to the database of cars. We've got a bank service that provides access to our database of banks. And the third piece of the puzzle is an application called Web UI that we're going to look at in just a minute. But I'm going to get it up and running and interact with it, and get a sense for what the application does, and then we'll back up and learn a little bit about how it does that. So I've got 3 applications running right now: Cars, Bank, and Web UI. Okay, now all 3 are up and running. And because they're all running concurrently, of course, they have to be running on different ports. And if you look down here, yeah, that's not being cut off there. But so that's the Cars. Yeah, the Cars application is running on port 8084. The Bank application is running on port 8082. And the Web UI application is running on port 8080. By default, your Grails 3 applications are going to run on port 8080. That's what most developers are going to expect, so that's a good default. And if you want to change that, there's a simple way. There's several ways to do it, but one way is inside of your application.yaml file, which is under grailsapp/conf. You can do this, right? So server.port is the name of the property that Spring Boot will look for when it fires up Tomcat, to know what port to start the Tomcat container on. So each of the applications, the bank, the car, and the Web UI, have different versions set. Well, so the Web UI doesn't set this at all. It uses the default 8080. In the bank application, I'm setting the port to be 8082. And in the cars application, what I expect to see here is 8084, and there it is. Right? Because I need all these applications running concurrently on the same machine, they can't share a port. So that's what that's all about. All right. Let's interact with the Web UI in the browser here and see what we can see. All right, so I've got a list of banks here. So I see Richie Rich Bank, Working Man Bank, and Poor Man Bank. And remember, as we try to follow along here, these are separate applications. They all happen to be running on my laptop, but they wouldn't have to be. They could be distributed to, we could deploy these things to Cloud Foundry or whatever platform we like. They happen to be running on one machine right now, but think of them as separate programs, because they are separate programs communicating with each other using REST as a mechanisms to communicate. So the app that we're directly interacting with right now is not the bank app, it's the Web UI app. But somehow the Web UI app is providing us this list of banks. So let's drill into that and see what's going on there. So in the Web UI, we've got a controller called Demo Controller. So we're in the Web UI now. And when I visit the index action, what the index action is doing is retrieving all the banks from the bank service and putting those in the model here, and then a GSP is rendered that represents this page right here. That's pretty Grails 101 kind of stuff. The interesting bit will be inside of the what's going on there when we retrieve the banks from the bank service. And remember, in Groovy, because of the way property access works in Groovy, bankservice.banks is the same thing, effectively, in this case, as calling bankservice.getBanks, right? So I'm invoking a method called getBanks on the bank service, right? That's how I'm retrieving the list of banks that will be used to populate this list. And again, remember, we're in the Web UI app. We don't have access to the bank's database. There's no bank information in the Web UI app. The Web UI app has to reach out to some other microservice. It's reaching out to the bank application to get those banks. This is how we're doing that. Let's drill into that service and see what that really looks like. So bank service, right? Here is the getBanks method. So this is what we're calling from the controller. And what the getBanks method is doing is creating an instance of that REST builder that we talked about. It's sending a GET request to some URL. We're going to get to, we'll see where this is initialized in a minute. In fact, let's look at that right now. So we're inside the bank service, and the bank service has a property called bank query URL. Bank query URL. let's go look at our application YAML for this particular app and scroll all the way down here at the bottom. How many of you take advantage of Grails' bean property override support in config.groovy? Anybody know what that is? Yeah, see a number of hands. A lot of people aren't even aware that this feature exists. But inside of your config.groovy in a Grails 2 application or in application.yaml in a Grails 3 application, you can define properties like this. So in config.groovy, it would be beans.bankservice.bankQueryURL equals some string. And in YAML, it's structured the way you see here. But what's going on here is if this property exists in this bean, it will be initialized with that value, right? So when the framework creates the bank service bean, it will initialize the bank query URL property to be this string because of the code that we're looking at here. So we don't have to go into resources.groovy. We don't need a bean post processor. There are a lot of ways we could go about getting this value into our service, and this is probably the most simple. At least if all we need to do is have a hard-coded value and we want it in a config file, this is the most simple way to do that. So this is the URL that will invoke the REST service in the Banks app and will return a JSON representation of all the banks that the system knows about. Does that make sense? All right, so that property makes its way into here. The property on line 8 is initialized with that value, and that value is used down here. We create a REST builder, send a GET request to that URL, retrieve the JSON from that what comes back, and that represents all of the banks in our system. Remember, 2 different applications. We're looking at code that's in the web UI. We made a REST call out to the bank app. This is going to iterate over all of the JSON, and for every bank that's in the JSON, we're putting that bank inside of a new collection that'll be returned. But at the end of the day here, when we get down to line 28, what 28 is a list of maps. It's a list of maps, and each map represents a bank, right? This is one bank right here. And that's being used to populate this drop-down list. All right. Questions or comments about that 6 or 7 lines of code there? All look good? All right. All right, so we've got our application making a REST call to some other application, getting some data back, and using that data to do something useful. In this case, that something useful is populating this list. So let's say we want to go to the poor man's bank, and I want to search for cars that are compatible with my bank, right? I'm a poor man. I've got credit rating problems. The poor man bank is the only bank that I can go to, so I need to find cars that are compatible with that. So I click search, and I see that I can get a Plymouth Duster for $200, and I can get the $200 from that particular bank. If we go to the working man's bank and execute the same search, I still see the Plymouth Duster, but I also see a Ford Fusion that might cost $22,000 because the working man bank has a higher threshold. I think it was $25,000 or $50,000, but it was higher than $22,500. And if we go to the Richie Rich bank and do the same search, we see more cars, including that car that I created interactively earlier with that curl command, right? So the Richie Rich bank has a cap of, I think we saw it was $250,000 or $500,000. So every car that's under whatever that threshold was is showing up in these search results. So let's see what some of that looks like. So again, we're in the web UI application here. And this is the code that generated the initial page where I see the list of banks. And then I select a bank from the list, and I click search. And that's going to invoke this action. So I click search, and there'll be one request parameter in the request. And the request parameter is going to be bank ID. In fact, let's take a quick look at the corresponding GSP and clarify where that's coming from. There we go. This GSP right here is responsible not for the page we're looking at now, but this page. This page has a drop-down list and a search button. This is the GSP that's creating that. So the drop-down list is this guy right here, and the option key for our drop-down list is ID, and the name of the drop-down list, the name of this select item is bank ID. So what's going to happen is when I click search and the HTTP request is made, the HTTP request will be made to the search action in the demo controller, and there'll be a request parameter whose name is bank ID, and the value of that request parameter will be the ID of whatever bank is selected in the list. Right? So this might be ID number 2. When I click search, that number 2, the value 2, is what will be passed as an argument into this search action. Right? So we're told that we want to search for cars that are compatible with a certain bank, and this is the ID of that bank. So the first thing that we do here with that piece of information is reach out to the bank service and say, give me the bank whose ID is bank ID. We can't just send a query to the database here. We can't do this. Right? I can't say bank.get bank ID. So why can't I do that? Yeah, it's not even in our app, right? So our app doesn't know about the bank class. There's no GORM here. I can't send a query to the database. I don't even know where the database is. It might not even be a database. There might be some other way that banks are conjured up. So I can't send a query to the database to retrieve a bank. What I can do is make a REST call to some other microservice that knows about the banks. It says, hey, I've got an ID of a bank that I think exists. Go find that bank for me and give me that bank. So that's what's going on line 15 here. Yeah?
So since this is also wonderful, it makes me a little greedy. Is there any work being done so that eventually I could configure it and just say bank.get?
The question is, it started with a comment, a quite beautiful comment I might add, that said this is all so super slick that it makes me want maybe even more. And then the suggested more is that could this be enhanced such that instead of having to make a REST call someplace, or at least instead of being explicit about making a REST call, could this somehow one day be evolved so I could call bank.get, so I could do this, and have that work? Is that a good restatement of the comment in question? The answer is yes, you can do that. So there is a, so GORM, I mentioned at the very, very beginning that GORM is expanding its reach, and we're targeting more and more ways to take advantage of GORM. And this one in particular isn't new. I think it's been there for, Dave, any idea? A couple of years, something like that. We've had GORM for REST for a while, maybe a year. So there are lots of different GORM implementations. There's a GORM implementation that uses Hibernate. There's a GORM implementation that uses Cassandra. There's one for Neo4j and MongoDB and so forth. And there's a GORM implementation that uses REST behind the scenes. So if we were using the GORM for REST implementation, then exactly what you see in the comment on line 15 would work. We can send queries. It looks just like a database query, but it's not. It's just a query. And instead of using Hibernate to generate some SQL to go to a relational database, instead of that, then a REST call is made, and you get to control the URLs that REST call goes to. So GORM for REST is what you were asking about. That exists, and it's super duper slick. All right, but we're not using GORM for REST. We've got this bank service that must have a method called getBank, that guy right there. So let's take a look at what getBank looks like in the bank service class. There we go. This is getBank. So we pass in a bank ID. A new REST builder is created. We send a request to this URL. So again, we're using bank query URL. That's a property that's initialized in application.yaml. We're making a REST request to some other microservice, getting some JSON back, parsing the JSON, and we're foregone any kind of error handling here. We're just assuming the happy path. And what's returned from this method call is not a bank. Notice that we're not creating a new bank like that because we don't have a bank class. We could write a bank class, and there might be a good reason to do that, but we don't have to write a bank class. We can take advantage of Groovy's dynamic typing and just return a map. So whatever calls this needs to know that the thing that's returned has a name property and has a max loan amount, but it doesn't have to know about any concrete type. It just knows there's a name property and a max loan amount property, and we're taking advantage of that right here, where I retrieve the bank's name, and we don't see the loan amount being used here. We'll see where I get the loan amount in a minute. So on line 15, I made a call into a service to give me a bank. I got back a bank, and then on line 16, I'm making another call to a different service that says, give me the cars that are compatible with this particular bank. And this is an inefficiency in the way this demo is put together, and I'll clarify what I mean by that in just a minute. So here's our car service. So when I ask the car service for all the cars that are compatible with a certain bank, I'm passing in the bank ID. This thing is making another call to go get the bank again, right? So we actually retrieve the bank twice. A better design here might have been to pass in a dollar amount, but anyway, you see the mechanics of how all this works. So I pass in the bank ID. This code is going to go retrieve that bank from the service. That's going to make a REST call to go get the bank. Then it's going to make another REST call to this URL that says, go get me all of the cars that are under a certain amount. So we're talking to two different partners here. I communicated with the bank app and said, hey, what's the bank whose ID is 4? And now I'm going out to some other piece of the puzzle here, some other piece of my micro application architecture that can answer questions about cars. It doesn't know anything about banks. And I just say, give me all the cars that are compatible with, that are cost less than some dollar amount. So this URL is going to be something like /cars/25,000.json. So this is where the 25,000 is going to come from, right? That max loan amount. So I'm sending a request to something like /cars/25,000.json. Let's see where that comes into play. Let me go back to that car controller that we looked at briefly earlier. Demo car controller, there we go. Remember, one of the reasons that you might want to extend RESTful controller is to change the way, in the first example that I looked at in the slides, I think we were looking at query for object. List all resources is like query for object, but instead of retrieving a particular instance, this returns a list of cars in this case. So I'm handed a map that includes all of the request parameters, and I can do whatever I want to do with that map, but what I need to return from this method is a list of car objects. So here we're taking advantage of, keep coming back to GORM. This is where queries are just a really, really powerful, really cool thing offered by GORM. It's a way to express a query, and the way that you express your criteria is in Groovy code. This is Groovy code right here, right? Line 14. That's not SQL, it's not HQL, it's not some query line, it's just Groovy code. So we've got these really sophisticated compiler stuff going on at compile time that will recognize this code as a query that's being sent to the database, and then we turn line 14 into a bunch of Hibernate stuff, or a bunch of stuff that's compatible with whatever GORM implementation you're using. So we happen to be using Hibernate here. So all the stuff that it takes to create a Hibernate criteria object and create criterion for the price, and all the Hibernate stuff happens as a result of line 14 here. It's just super slick stuff. So there's going to be a request parameter. Sorry, was there a question? Nope. There's going to be a request parameter called max price. That's going to be that last part of the URL before the JSON. The 25,000.json, 25,000 will be the max price. So I want to grab the value of that max price request parameter and use that to instrument this query. So what's returned from this call to car.where is only the cars whose max price, whose price is less than whatever that max price request parameter is. So again, over here, I go back to my car controller or car service. If I send a request to cars/25,000.json, that should give me only the cars whose price is less than or equal to 25,000. And that's what's going on here, right? So when I select this, that's the Richie Rich Bank, and click search. A call is made out to the bank service to retrieve the bank whose ID is whatever Richie Rich's ID is. We retrieve the max value from that bank and then use that to create a separate query to the car service, which returns all the cars that are compatible, or as far as the car service is concerned, what it's returning is all the cars whose price is less than some number. I don't know what happened there. It's returning all the cars whose price is less than some number. And the web UI is the application kind of in the middle that's facilitating communication between all of those. Right. Questions or comments about any of that? Yeah.
Where's the max price parameter name?
Yeah, the question is, where is the max price parameter named? Let's take a look at one where I'm referencing it first. So this code is expecting, it doesn't make the assumption, it checks first, but it kind of expects that there'll be a request parameter called max price, and we're going to use that to instrument the query. The query the URL that led into that call, I want to try to get all this code on the screen at the same time. The URL is going to look something like this, /cars/25,000.json. So we still don't see the answer to the question, but the answer to the question is in our URL mappings.groovy. So if we go look at our, make sure I'm in the right app, and I am, right there. So this is the second URL mapping that I mentioned earlier that we would get back to. So any request, so yeah, this would actually be automobiles under 25,000. So any request to a URL that is /automobiles/under/some number, right? Then dot format is optional there. So any request to automobiles/under/some number will be handled by the index action of the car controller. The index action is the action that by default will go retrieve all the cars and put them in the response. We have modified our controller so that we're not necessarily retrieving all the cars. We're retrieving all the cars by default, but if there's a max price request parameter, we only retrieve the cars whose value is less than that. So this, that URL mappings file we were just looking at, right here is where that request parameter name is coming from. Other comments about any of that? All right. So those are all three Grails 3 applications. We've got three Grails 3 applications. They're not all communicating with each other. We've got one communicating with two. So we've got a web UI application communicating with the cars and the bank app. The cars and the bank app don't happen to be communicating with each other, but they could. And this graph of applications making REST calls to each other can be as, there can be as many sort of nodes in that picture as makes sense, right? That's what we just did. So comments or questions or anything at all about microservices or REST inside of Grails or anything at all that I can help you with? Yeah?
So is there any changes from Grails 2 to 3 as far as REST support is concerned?
The question is, are there any changes from Grails 2 to Grails 3 as far as REST is concerned? And the answer is yes. So there are several sessions coming up through the week that are going to drill into this in more detail. Tomorrow afternoon, I think I've got a talk on Grails 3 REST, and I think there are a couple of others during the week you'll see on the schedule. One big thing that I'll take a few minutes to talk about right now is, well, one of the new features in Grails 3 are application profiles. And application profiles are really quite a big deal. And at first, maybe they look like kind of a nicety, but they're really a pretty important, pretty powerful new feature in Grails 3. So in Grails 2, we didn't have the notion of application profiles. So effectively, we had one profile. Every Grails 2 application was the same profile, and that is a full web application with GSP support and GORM by default and site mesh, all the stuff that you're used to using in Grails. That's kind of all in the application by default, whether you're using it or not. In Grails 3, we've introduced this notion of application profiles. And the default profile, if you type Grails create app name, the default profile is very similar to what a Grails 2 application looked like. It's a standard web application profile still with GSPs and site mesh and GORM and log, all the stuff that you're used to using in Grails. That's the default profile that you get when you type Grails create app. There's a syntax where you can type Grails create app -- profile equals profile name. And that's how you create an app with a profile other than the default web profile. One of the profiles that we're actively working on is a REST profile that is specifically for building applications that publish REST services. So if I were using that profile in our mix here, I would have used that profile, the REST profile, for the bank app and for the cars app, because they don't have any browser front end. They're just, that's what they are, is REST services. I would use the REST profile for cars and bank, and then I would probably use the standard profile for web UI. So the REST profile that's in the works now is one of the cool new things in Grails 3 that relates to REST. There's more to that that's related to that. And a big piece of that is we're working on an Angular SPA profile for Grails 3. So you can build Angular applications with Grails 3 now. You can build Angular apps with Grails 2. But what the Angular SPA profile is going to do for Grails 3 is it's going to put all the mechanisms in place that it's kind of serves some of the purpose that generated scaffolding serves in Grails 2. But it's going to put all the mechanisms in place that wire up your Angular controllers and services and all that stuff and make it very easy and very obvious how to build out an Angular application in Grails 3. So that'll have all the REST stuff for the server side, and it'll have all the Angular stuff rigged up for the front end. And look for announcements about that in the coming weeks. If it's months, it's a short number of months, like maybe 1 month. We're not very far from being able to publish some of that stuff. But that's important. Moving forward, more and more people want to build that kind of application. They want to build REST applications. And if they're building a browser front end for that application, they want it to be a single page type application. Angular is kind of probably has gained the most momentum in that space. There are others. There's Ember and other frameworks that play in that space, and will have support for all of the important ones. But Angular is the first one that we're working on. So building REST apps is more and more important to folks. So we're continue to evolve the framework to support that even better. And building single page type applications kind of relates to that. And for the same reasons, we're building out really, really slick Angular support for building that kind of application. Yes?
The values in application.yaml for the URLs, localhost, and the ports, when running in an actual deployed system, those URLs come from a config file on the environment or a service discovery, or what would your recommendation be?
Yeah, they could. The question was those values that I hard-coded in my application.yaml for URLs where I was going to go locate these services. Remember that these are all running on my laptop, but think of them as distributed things. So my web UI needs to know where to go to get car information. It needs to know where to go to get bank information. And so kind of the worst thing I could do is just hard code the URL in the service right where I'm using it. So I've improved on that by pulling it out of the service and putting it in a config file. And depending on, so I've got a number of options for how to manage that in a production environment. One thing I could do is I could have that be initialized at startup based on something that I retrieve from JNDI, or maybe something that I retrieve from a database, or maybe it's just part of our deployment instructions that, hey, when you deploy this app, you need to set this environment variable, and the application can pull that value from the environment. So you got lots of options for where that data might come from. The sample that I just showed is just getting the hard-coded value out of the service, because you don't want it there. And if hard coding it in the application YAML is sufficient and that's flexible enough for your deployment and for your requirements, then fine, do that. But you've got lots of flexibility. That information could come from a database. It could come from a REST call. You've got to bootstrap that. You'd have to know where to make that REST call, I guess. But you've got flexibility and options for where that kind of stuff comes from. Yeah, Scott.
So with Spring Cloud, I think you can, try to integrate with Eureka to discover where things are at. Can you try to do any of that yet?
Yeah, the question is talking about Spring Cloud and Eureka, and to be honest, I have not spent much effort at all investigating Eureka. It's on the short list, so I really can't speak to that. Yeah, Jack.
Come to my talk in the morning at 8:30, and you'll see it.
So Jack Frosch says, come to his talk at 8:30 tomorrow morning, and you'll learn everything you could possibly want to know about Eureka, I think is what I heard. Thank you, Jack.
So you cannot do a system.get property in the YAML. You have to put it in the bootstrap.group.
Yeah, the question is, can you put a system.get property in application YAML? And the answer is no, right? In your YAML file, it has to be YAML code. You can't put Groovy code in your application YAML. But what you can do is, so in addition to application YAML, you can have an application.groovy file. And that works a lot like the old, the Grails 2 config.groovy worked. So you can put Groovy code in there. There are some issues with having both application.groovy and application.yaml side by side that we're working on what the best solution for that is. Right now, mixing them is potentially problematic, so you should have one or the other. But application.groovy goes in Grails app/conf, the same place where config.groovy used to go, and the same syntax. You can just rename your config.groovy to be application.groovy and you're on your way. But you cannot put Groovy code in application.yaml. That it wouldn't work. Groovy code has to go in a Groovy source file. Anything else? Another question? Feature request, tips? Yes.
With microservices, it seems like you could easily have redundant domain objects, especially if you use that nitpick plugin. I figure the two answers to that are either you probably should have put it in a single app if you keep using the same domain objects, or that's just the nature of the beast. Is there kind of a third better answer?
Yeah, the question is, question/comment is, you might end up in a situation where you've got multiple copies of the same domain class if you were using REST for GORM. Is that what the scenario we're talking about? So how do you go about that, right? So it's true, you could end up with multiple copies of the same domain class in multiple apps, and you want to try not to do that. So one thing we could do is I could have the bank app have a bank domain class, and I could have the web UI app have a bank domain class, and the bank app could be using Hibernate, and the web UI app could be using GORM for REST, and doing that. That's can be made operational. That can be made to work, but it's potentially problematic because you've got two classes, and one could evolve without the other, and that's going to get a little bit tedious. So one thing you might do with that is define the domain class in a plugin and have the application share that plugin. That's one option you've got. Another is only have the domain class in the application that's actually persisting it, right? That would be in the bank application in our case. And in the web UI app, don't have a bank class. Do what we did here. I'm just passing maps around that happen to have attributes that make up a bank. Often what happens is we end up with two different classes that serve two different purposes, but they both represent a bank. So in the bank app, I've got the bank domain class that has bank name and max loan amount and whatever it is that makes up a bank there. And in the web UI, I've got kind of a different notion of a bank that might be a superset of that. So in my web UI app, I might have a bank class that's not a domain class. It's just a class out under source main Groovy or someplace. And it happens to have some of the same attributes as the bank class, or maybe it has an attribute that is a bank, or no, you can't do that. So it could have some of the same attributes that the bank class has, name, max loan amount, and then maybe some methods in it, and maybe some other attributes. So it's sort of a DTO. It's a representation of a bank in my application that is not the same representation of a bank that's in the bank app. So I make the REST call to the bank app to get its notion of a bank. I construct these DTOs over here in the app, and I've got all this additional behavior that's in methods and so forth that I might define in the bank class that's in the app. So you've got lots of flexibility around that sort of thing. Does that make sense, what I just described?
And one add-on question to that, if your source of truth, which actually persisted the domain object, if you then had another app that had the same domain object but a subset of the fields, it would just ignore some of the JSON, right, in the REST call, and cast the subset of fields, so that even if you added additional fields to the main object, it would just ignore them on the other app.
Yeah, so
Be advisable,
I need to restate the question, but I want to make sure I understand the question. Are they both domain classes in the scenario you're talking about?
Yeah,
Okay.
So one actually persists it, one uses REST for GORM, and it just ignores some of the field that comes in JSON.
Yeah, so the question is, or comment is, could I have two domain classes that each represent a book in two different apps? One has two properties, and another has those two plus more properties, a superset of properties. And how would that play out? So if the real truth is the one that has the superset of properties, the longer list, then when the application that has the smaller version of that class tries to constitute one of those from the JSON that includes all this other stuff, that can be, the data binding mechanism can easily be configured such that all the extraneous stuff is not problematic. It just doesn't do anything. The other way around is true as well, right? So if the real source has the shorter list of properties and the application has a longer list of properties, when you create the thing that has the longer list of properties, you're only going to be initializing the ones that correspond to the shorter list, And now you've got all these other properties you can manage, in the application however is appropriate. Yeah. Does all that make sense? I need a whiteboard, I think. Yeah. Probably got time for one more question. Anything else? Yes.
Just one final question.
Sure, go ahead.
If I had created a Grails 3 project by using the default profile for a REST project, REST API project, do I have to go back and do a REST profile? Will I be missing anything?
So
We started a project with Grails 3, but it's actually a REST API project which is using a default profile.
right.
Do I have to go back and
Yeah, so the question is, if I create an application today with Grails 3 using the default profile, later when the REST profile is finalized, what am I missing? Or
no, the REST profile is not even fully done. Is that what you're saying? Or-
That's right.
Okay, so I'm not missing anything if I have already started.
Yeah, so if you created an application with the default profile and you started building REST, the applications we're looking at now were all created with the default profile. You're not, so later, depending on what ends up in the REST profile, there could be new things there that you're missing, but we won't know until that's all finalized. But you could turn your application your application could easily be adapted to take advantage of whatever is in the REST profile or any other profile that's created in the future later. Then the details of how to do that would depend on what are in that profile. But this isn't strictly true, but in general, all the cost that you're going to be paying is you've got more stuff in your app than you need. You've got GSP support there, and you've got site mesh, and you've got stuff you're not using where the
Project is more bulkier.
That's right, and your WAR file is going to contain some stuff that you don't care about that doesn't need to be there. That's
It's got to do with performance. Just bulkier.
it can affect performance because the more stuff that's there, you're affecting what has to be loaded by the JVM. So even in Grails 2, if you're building a REST application, you're not using GSPs, and there are features of the framework that you're not using, you can still whittle those things down and not include them in your WAR file. But you kind of have to cherry pick. You have to know what to exclude. But there's a simple way for you to say, hey, Grails, when you build my WAR, don't put these things there. But you have to know the details. It's not super slick. It's totally manageable, but it's something you have to know about. Where if you create an application with the REST profile, all that's going to be there is the stuff that is almost certainly going to make sense in that application, and you're not going to have this extra baggage of jar files that you're not using in your WAR file. That's really it. All right, so if you've got other questions, I'll be here pretty much all week. Please come let me know. I'd be happy to talk with you about anything you like, Grails, archery, anything you want. Thank you all very much.